Chapter 5 begins with a section on balancing chemical equations. Balancing chemical equations is just a fancy way to talk about chemical accounting. Now, in the movie Shawshank Redemption, there was a lot of accounting going on. In this case, Andy Dufresne, who was the inmate, was used by the prison warden to steal and hide money. Now, the reason for this is accountants must keep track of the flow of money, what comes in and what comes out, and Andy was very knowledgeable of tax law. Because of this, he was able to exploit his knowledge and figure out where the loopholes were to help the warden steal and hide money. Now, chemical accounting is similar, not in the fact that I'm trying to encourage you to commit crimes like the warden was, but instead allowing you to control the chemistry. Because when the chemistry is right, you can get busy living. Chemistry really that's controlled is wonderful. And so chemical accounting is the first step of trying to figure out how to control the chemistry. So in this example, we have a teeter-totter, which is supposed to represent the balance between reactants and products. In this chemical equation, hydrogen gas is reacting with oxygen gas to form water, but that is not a balanced equation. If you look, there are 2 red balls on the left, 1 red ball on the right, 2 white balls on the left, 2 white balls on the right. And the reason for that is anytime you got hydrogen and oxygen combining into water, it's going to be an oxygen in the middle with 2 hydrogens attached to it. But if you look, they're not equal. There's only 1 red on this right side, which means that is going to be a lot less atoms than on the left side with its counterparts. So what we need to do is we need to balance the teeter-totter, account for the change in atoms by balancing this equation. So when we're doing this, we need to ask ourselves, what do we need more of? More reactants or more products? And just change the coefficients of the chemical equation to account for those changes in atoms. So in this situation, we need more waters because we need more red balls, more red oxygens. So in order to do this, you change the coefficients, and let's try a 2, because now if we have 2 waters, that means we have 2 of those water molecules that you see on the teeter-totter, which creates 2 red balls. Now we're balanced for the oxygens. But we're still not balanced with hydrogen because there's 2 hydrogens on the left, 4 on the right. So in order to account for this, we're going to place a 2 in front of the hydrogen. Now there are 4 hydrogen atoms on the left and 4 hydrogen atoms on the right. 2 oxygens on the left and 2 oxygens on the right. So now it is balanced. In any equation that has been balanced, you will always see that the same number of atoms reflected on both sides of the arrow. But there are some rules that you need to make sure you follow. So rule number 1 is when you're balancing an equation, you can never change the subscript or the atoms that are attached. Because if you're changing water by making it be H2O and changing H2O to H2O2, you no longer have water. It goes from water, which you can drink readily, to H2O2, which is hydrogen peroxide, which would burn you if you drank it. So you can't just change up the subscripts and the atoms all willy-nilly. You can only change the coefficient. So you're changing these coefficients to balance the equation. The nice thing about this is practice will make you very good at this. The more you practice, the more quickly you will see the left side and the right side just kind of balancing well. So we're going to practice. I have 5 chemical equations that we're going to do. Feel free to stop the equation anytime you think you're getting it. Just stop the video, and try and balance it on your own. If you think you need more practice, then definitely go along with the video. But I recommend writing down all of these reactions and going along with the video. Our first equation we're going to balance together has nitrogen and hydrogen reacting to form ammonia. So the first thing I do anytime I balance a chemical equation is I write down the atoms that are involved in the reaction right down the middle where the arrow is. So I have nitrogen and hydrogen are my 2 atoms involved in the reaction. Now notice I didn't write N2 or H2. I just wrote down the atoms, not the molecules. Once you've written that, then you ask yourself how many of those atoms are on the left and how many are on the right. So there are 2 nitrogens on the left and 2 hydrogens on the left. Then there's 1 nitrogen on the right and 3 hydrogens on the right. So I can tell quickly that these molecules are not balanced. So in order to change that, I know I need 2 nitrogens. So let's place a 2 in front of the ammonia. That causes not only my nitrogens to change, but also my hydrogens. And so now my nitrogens are balanced, but my hydrogens are not. I only have 2 on the left and I need 6. So in order to do this, I can place a 3 in front of my hydrogens because now 3, which is my coefficient, times my subscript, which is 2, equals 6. 3 times 2 equals 6, and that's how you will always calculate how many atoms you have. You could also draw it out pictorially, where you could draw out 2 individual atoms attached together, but now you have 3 of them. That means you have 6. So now this equation is balanced. You can leave it like this, or you can place a 1 in front of the nitrogen. For our next example, we have potassium chloride reacting to form potassium chloride and oxygen. So let's do the same thing. Write down all of the atoms in the middle. Then ask yourself how many of each atom is on the left, how many of each atom is on the right. Now we need to look and say what is not balanced. So in this case, I could start immediately playing with the oxygen, or I could try the potassium chlorate. I personally always start with the more complicated molecule first, unless I can see mathematically that it probably is not going to work. So in this case, if I had just started with oxygen, I might have placed a 2 in front of the oxygen, which would mean there'd be 4. So then I would have to go to potassium chlorate and try a 2 at that moment. And then I would just have to erase my 2 I had placed in front of oxygen and try again. So let's just say I start with the more complicated first instead. I can never just subtract atoms, I can only add to them. So in this case, I tried placing a 2 in front of the potassium chlorate to start, which means now I have 2 potassiums, 2 chlorines, and 6 oxygens, because 2 times 3 gives me 6. So now, nothing is balanced. It makes it look like I got a whole lot worse, but in actuality, I can now go and balance my potassium and my chlorine and my oxygen. So if I place a 3 in front of my oxygen, that means I have 3 times 2, which is 6, and then I can place a 2 in front of my KCl, which would give me 2 potassiums and 2 chlorines, and then I still have my 6 oxygens. Now my equation is balanced. Let's try this equation. Feel free to stop the video, try it on your own, and then compare your answer to mine. Let's start by writing the atoms in the middle. So now I come up with how many of each atoms do I have on the left side and on the right side. Then I ask myself, what is not balanced? Let's go ahead and try balancing the sodium chloride first. So if I place a 2 in front of the sodium chloride, that makes my chlorines balanced, but it makes my sodiums unbalanced. So now if we go to the product side and try and balance out those sodiums, I place a 2 in front of the sodium fluoride, which balances my sodiums and my fluorines. And so now I'm completely balanced. I could place a 1 in front of my fluorine gas and my chlorine gas, or you could just leave it blank. But now it is balanced. Let's try this one together. This one's a little more complicated looking. Just a quick reminder that all element symbols will start with a capital letter. If you see a lowercase letter like the B, that means it goes with the letter that was prior to it. So that's why your PB is capital P lowercase b, that stands for lead, whereas chlorine is a capital C lowercase l for chlorine. Same principles still stand. Place the elemental symbol for each atom that is in the chemical reaction in the center. Then ask yourself how many of each species exists on the left and how many exist on the right. Something to be aware of is if you ever see parentheses like this with the subscript outside of it, that means the 2 goes to both the oxygen and the hydrogen. So in this case, it's O2H2. So you have 2 of each of those species. Now you remember I just said there's 2 hydrogens, so why did I write a 3 right here? So remember you have to look at all of the atoms on the left side of the equation. So in this case 2 hydrogens come from lead hydroxide and 1 comes from hydrochloric acid. So 2 plus 1 gives me my 3. Then you count each of the atoms on the right side. So let's start by balancing. How about your hydrochloric acid? The reason I chose that was because this looks pretty balanced with the 1 and the 1. So I'm going to go ahead and just start with the chlorine. Okay, you could start at a couple different places here, and that's okay. You'll still get to the end at the same place. So I'm going to start by placing a 2 in front of hydrochloric. That's going to change my hydrogens and my chlorines. Notice that did not just take 2 multiplied by this 3. Instead, I have to count how many hydrogens are on this side total. So now 2 are coming from the hydrogens in hydrochloric acid, and 2 are coming from the hydrogens of lead hydroxide. So 2 plus 2 gives me 4. I still have 2 chlorines. All right. Next, let's try and balance out those hydrogens. So if I place a 2 in front of water, I now have 2 times 2 gives me 4, and 2 times 1 for oxygen gives me 2. And now I am perfectly balanced. I could even place a 1 in front of my remaining species. Once you have it balanced, you're done. Okay, next, let's try this one. I do have a tip that I like to use for this compound, and that is if you ever see a functional group, and that is a sulfate in this case, represented on both sides, then you know you can just write down the sulfates and balance the sulfates. What I mean by that, if you see how SO4 is in parentheses here, that's a functional group. It is a group of atoms covalently bound together. Okay, and so with sulfate, it's over here and it's also over here. So you could down the middle write sulfur and oxygen separately, or you could just write SO4. So anytime you see these bigger groups on both sides of the equation, go ahead and try that. It just gets a little bit of time, I think. Or if you don't want to, you can just put S and O. But they do need to be on both sides, and there needs to be nothing else somewhere else. So meaning the sulfur can't be somewhere else, and the oxygen can't also be somewhere else. Okay, they have to be in the functional group and nowhere else. So I place all of my elements, symbols, all the way down the middle by the arrow, and then I count up how many are on each side. So notice I have 1 aluminum, 3 bromines, 2 potassiums, and 1 sulfate group. Then on the right side, I've got 1 potassium, 1 bromine, 2 aluminums, and 3 sulfate groups. This 3 out here is for the whole group, so there are 3 of this group, and that's where it helps me save some time. Alright, so let's start by placing a 3 in front of the potassium sulfate. And the reason I did that was because I noticed sulfate was one of my more complicated parts of this equation. And so if I place a 3 outside of it, now I have 3 sulfates on the left and 3 on the right. That also changed my number of potassiums, so now I have 6. So then I can now choose to either go back and balance my bromines first and my potassiums, or I can choose to just keep balancing on the left. So in this case, I notice that aluminum is also misbalanced, and so I'm going to put a 2 in front of aluminum bromide, which is going to change my aluminum to be 2 atoms and my bromine to have 6. And now I'm completely heavy on the reactant side, and I need to add more atoms on the right side. So let's place a 6 in front of potassium bromide, which is going to balance both my bromine and my potassium, and then I could also place a 1 if I wanted to in front of my aluminum sulfate. But you will notice at this point I am entirely balanced. So now I need you to go read section 5.2 and then come back to watch the video on that content.